Welcome back everyone. Now we are going to learn about the mapping. You might be pondering that why we are learning again the mapping. Oh, we just seen that how the maps work, so why it is here. Yes, you're right, my dear friend, but there is a logic behind teaching this topic in a separate video lecture. Okay. So what is the reason? Well, you will be glad when I will tell you the reason. Why it is so? Well, we have studied the main memory in detail, right? So we have studied the main memory, and we also have seen the basics and the entire thing about the cache memory. So how do we do it? We make a map. We make a map between those two things. We need a mapping, and that's why we are studying the mapping. So let me explain you in a more broad way. Just listen to my words carefully and you will understand that why we are studying the mapping here and what it is. The transformation of data from main memory to cache memory. This is our main memory and this is our cache memory. And the transferring of the data from main memory to cache memory is referred to as mapping. So this is mapping, as I also mentioned up here, but I am just making it so that we can understand it more clearly, and I will tell you why. Okay, what else we have here? There are three types of the procedure. As you can see, I have written that already: direct mapping, associative mapping, and set associative mapping. So we are going to study these all the three in detail. And what else we have here is actually for every word stored in cache, there is a duplicate copy in the main memory. Like if I have a photo, let's say if I have something like, let's say I have the number 5. So the number 5 in the cache is a copy of the main memory. They are the copies. You can call them carbon copies. I am just calling the copy. So these are the copy things. The CPU communicates with both the memories. So CPU is not discriminating or something like that. CPU is communicating with both of them. And whichever information it gets faster, well, it gets easier for it. And surely it is also connected. So everything is connected up here. It first sends address to a cache. If there is a hit, means you have found the address in the cache, it accepts the cache. But if it misses, it goes to the main memory and look for itself that where it is, where the data is, where the actual address is. That's the complete story. So the main memory can store 34K word or of 21 bit each. The cache is capable of storing 512 of these words at any given time. For every word stored in the cache, there is a duplicate copy in the main memory, as we have discussed. The CPU communicates with both the memories. Well, I'm just reciting the summary again. Don't get bored with this thing. I'm just repeating the things. Okay, let me make it a little more exciting by presenting it in this form. This is our main memory, and in the main memory we have 32K kilos multiplied 12. So this is something, and here is our CPU that I am mentioning, and finally we have cache memory, which is having 512 multiplied 12. Well, these are numbers are just for the example purpose, and for the practical life we can have more or less of these numbers as according to whichever machine or computer we are talking about. So this is how it's working, and these are the numbers that I just told you. So um, to discuss various mapping technique of the cache mapping, we consider cache consists of 128 blocks of 16 words each for a total of 2048 words. 2048 words, and assume that main memory is having 64 words. So you can clearly see the difference between them. 2048 word and 64 words. So which will going to be faster? You can surely know about this thing. Don't think that it is having less memory and it is having more memory. There is nothing like that. It is having more clear mapping and it stores the address. That's it. And it stores the address also, but it also stores the location of the data. So main memory has to handle the entire society, you can say. And cache memory only handles the address. So surely there are easy access and less work for the cache, but it is fast so that we can go to the exact place wherever we want. That is the entire purpose of it. Okay, so in the next one we are going to study and start from the direct mapping, and we will study the direct associative and set associative mapping all in once. So get ready for roller coaster ride. With all that said, see you in the next one.